go. Start recording. You're good. All right, so let's continue. All right, so that would be a sentence. We're saving a problem. The condition now, you have two sentences. And not to worry, it could be a rough sentence. I'll fix it up for you. So you're going to say now, the required mechanics of the jig, for example, is that it should hold the flange without support from any other attachment. The design should be accounted for so that 3mm hole can be drilled. It should also be used without having to find its center. But where did this condition come from, you might ask? Well, let me show you. All right, so when you're doing your SB, I'm going to give you now some conditions that the manufacturer requires of you. All right, here we go. Let's go here. Excellent. So look at this for me now. So here's the conditions that the manufacturer came to you and said that they want to do business with you and we want these problems to be solved. Loading. Here we go. Page 3. Okay, good. So they come to you and say, this is what we want to make, right? We want it to be drilled at 45-degree angle, so I want it to drill here, right? But the process that it takes to drill one is so time consuming, and we want to drill 1,000 a week. So we are coming to you now to design something to hold these devices without finding the center, so it's easier to drill them and we can produce more. So here are the conditions they told you, right? They said, for example, we wanted to do these things. Hold the flange, which is this, right? Securely without any other attachment. Designed so that the position would be guided directly into the hole. Be sturdy, right? Allow for the flange to be quickly inserted, so not any additional attachment to it, and have a means of aligning to the drill table. So this would be self-aligned. And I'll get through what that means. So when you see these requirements from the company, or from the SB that I'm going to be showing you Monday, right? You're going to summarize that into the one section. Here we go. So when you summarize it, you're going to give two sentences now that essentially tells what the actual process of it should be. It should drill a 3mm hole, and it should have to do so without finding the center. Then now the principles that they required of it now would be what you summarize. They say that it has to be durable, be self-aligning, have an ease of release, and it must have a guiding mechanism. All of that was really from, let's go back, this section. So those 4 lines are really from everything here. So you're going to learn how to summarize content. All right, then now your design will be your idea. So based on the problem that they have and the conditions that they want, you're going to come up with an idea. Right, in this project, I thought of a jig. All right, let me show you what a jig looks like. Jig, drawing, engineering drawing. Let's look at what a jig is. So a jig is really a supporting device like this right here. So it holds something, right, and you can essentially tighten it or align it. All right, so I use that principle of a jig now to design what this wanted of me. But in other words, the jig is a flat surface, but the question didn't say it was to be flat. It said it to be at a 45-degree angle. So that means I had to modify what a jig would be, and that's where your ingenious comes in. So it says, the jig is aimed to fulfill the requirements listed above. My design comprises of a V-block, let's highlight V-block, and a vice grip, right? I'm pretty sure Corey and you guys know what vice grip means, right? You have a device that could tighten something.
Yes, sir.
Right? But a V-block now is a design of the jaws of those things. Let me show you. So if you have a V-block design, essentially the outline of it looks like a V. V-block vice grip. Right, here we go. All right, so the outline of it looks similar to a V. So I use this principle now to come up with an idea to create a device that could hold this flange in a V shape. All right, let's go back. Excellent. Then now I said that was the first part of it. So that was the idea. Now tell me what the idea can do. To secure the flange, which is the principle, that was the concept behind getting a vice grip to hold something. The guide is attached along a stationary V-block mouth. Then the design is functional and an original workpiece. So I hope it fulfills its purpose. So that goes without saying. Your idea must be original and innovative. It must not be something that's created already. So in other words, this genre that I had wasn't created before. So that's why I said it was a good place to start and create an idea and make essentially a business from it. So here are the tools now that I said I needed, and I'm gonna go through these now. So the part sheet I'll show you in a bit. I'm gonna go to the parts sheet now. So before we go there, everybody understand here? So this would be worth 7 marks.
Yes, sir.
Right? So you're gonna have this to follow off of, right? I'll give you after class, and then you're gonna create now yours Monday when I give you the criterias. Right? But let me show you what a parts sheet is. So go here. One moment. It's gonna take a bit to load up. All right, so let's go back here. So while that's loading up, let me just quickly go back here. So after you finish now the business plan, I'm essentially gonna mark you based on originality, functionality, suitability, and your essential design. All right. Then now here's the part that comes in where students tend to fail off. You need these things. So you need a pictorial drawing, you need a parts sheet. Remember, parts sheet. You need a sketch, a sectional view, a plan view, and a parts list. And I'm going to go into those now. All right, so we're at this section. So we're at section C. All right, section B, as I said, is worth 7 marks. Section C now, this should have loaded up already. Hasn't. All right, not to worry, not to worry. Google Drive. Let's go here. All right. So now let me show you now the idea that I had. Let me show you quickly. So the idea that I had really. All right, so that's a sectional view. And here is the design, really. Excellent, here we go. So this is now my design to create a device that could drill at a 45-degree angle. All right, so we'll call this a jig design. Let me show you the sectional view. So, as I said before, the sectional view is where you cut it in half, right? You detail, right, which section you would see. So in other words, you wouldn't see this section. Let's go back on isometric because that section is, as I said before, this empty space. All right? You would, but,
Yes, sir.
but the thing I want you to understand about it, do you realize that there's different types of hatches for each section?
What do you
Right?
mean by hatches, sir? Like,
So these lines that you see that goes across diagonally, those are called hatching lines.
yes, sir. Yes, sir.
Right? Up here, because it's not a part of this hatch, we use a different type of hatching, and I'll show you how to hatch later. Right? But essentially, to show that you have different components of our design, right? To show that this is totally separate from this part, you use different types of hatches when you cut it. Right? Okay, let me go here now. All right, excellent. Let's load it up. Let's go here. Okay, good. So now we're going to learn what the parts list is and how to really detail that. Okay. Okay, so in the parts list, you're going to be telling me all the different types of materials that you would need to create your idea. Remember, I'm here 100% of the way, so you're not going to really think that, oh, I have to really create this idea from scratch and no one is here to help me. I'm here to really follow you in it. and give you a guide. Okay, good. So let's look at the first section of it. Okay, it's loading. I've never seen Google behave so slowly. All right, here we go. So this is essentially what we call now your engineering drawing. So in this section below here, it's gonna be called your title block. You know that already.
Yeah, you're breaking up.
I'm breaking up. All right, hold on.
Hello?
1 second. 1 second.